Hello, my name is Vlad Raducanu, and in this video I'm gonna make a presentation of our project chosen for the Digiland 2017 contest, which is called the Automated Printed Circuit Board Soldering System. As you can see, the concept of our project is pretty straightforward, as we mounted a soldering pan on a RC motor driven robot arm. The robot arm communicates with the Digiland Basis 3 FPGA board through through an interface, which is actually a PMOD-Con 3 interface for servo motors available at the Digiland website. We took the schematics and specifications from there and made a replica. It also has a joystick, a 2-axis joystick provided also by Digiland, and this joystick enables us to move the robot arm to a certain solder pad on a prototype printed circuit board, just like the one we used for our PMOD-Con 3 replica. But right now the arm is not capable of moving to a real soldering pad location because it's not calibrated. Anyway, the purpose of our video and mostly our project is to demonstrate the fact that we can command an actual robot arm or send commands to the outside environment using the Digiland Basis 3 FPGA board, and throughout the graphic user interface displayed on a VGA monitor, which is probably the core element of our project. As you can see on the VGA screen, there are displayed some green dots. These green dots resemble the actual soldering pads that are located on a printed circuit board, which was destined for prototypes. And the cursor, the little red cursor that enables us to do the actual selection. When a pad is selected, the robot arm moves to that pad, even though right now it's not able to do so. But after we will calibrate it, it will work just fine. And each time we make a selection, the selected pad turns from green to blue. This allows us to keep an evidence of the soldering pads that on which an actual soldering operation has been made. More so, we can use this feature for memorizing the locations we want to solder, and first we can introduce them and then store it into memory, which will memorize the commands and execute them in the order of their selection. Right now we will reset our system, and the arm goes into the 0 position. All the 3 servo motors of the arm go into the 0 angle position, and the blue dots vanish, and soldering pads turn back to their green color. Another element of our graphic user interface is the red mark located in the top left corner of the VGA monitor, which enables us to know when the screen is perfectly calibrated. So as long as we can see the red mark, and as long as it is located in the upper corner, left corner of the screen, it means that the image is perfectly centered. So we are able to see all the soldering pads displayed on the screen. On the basis tree board, we enabled the 7-segment display to permanently display the coordinates of our selection. As we move on the y-axis, it changes from 1 to 18. As we move left and right on the x-axis, it changes from 1 to 24. That means that that resembles a little perforated prototype printed circuit board that has 24 rows and 18 columns. Yes, you may think that I've made a mistake by saying that the actual rows are columns, but this is not the case, because on printed circuit boards used for prototyping, the actual, I have one right here. Well, it used to be right here somewhere, but and yeah, I found it. But anyway, on printed circuit boards designated for prototypes, the rows are actually numbers, and the columns are letters. And as we can see here, it resembles the exact image of our display, which means that there are more dots on the x coordinate than on the y coordinate, which means that we have 24 dots on the dots. There are soldering pads on the x-axis and just 18 on the y-axis, just like our graphic user interface. But as we mentioned earlier, we are not yet able to do actual soldering operation, because as you can see, the arm moves in a chaotic fashion. It is not yet calibrated, but I'm pretty sure that once we will calibrate it, it will work just fine. The goal of our project is mostly to demonstrate that we can actually command a servo motor robot arm through the means of a VGA graphic user interface. So this was our project, and I hope you enjoyed it. Have a nice evening.